Hi, this is Arun. In this video, we'll have a quick look at stack and queue. This is one of the simplest data structures which you can learn. It is nothing but a different form of an array. I say different form, it's a constrained version of an array. Okay. Stack is a general day-to-day thing, like when you have a stack of books, it's like one placed on top of other to a certain limit. That's called stack. And queue, in any country, especially, we know what a queue is and what is the impact of a queue is and how fights happens in the queue. Okay, so to simply put it in the analogy into a programming context, like a stack is like last in first out. I mean, you have to take the topmost book out first so that it doesn't fall. That is a physical constraint which they have, and we apply the same constraint to programming as well. That's called stack. Whereas queue is like whoever comes in first will goes out first. It's first in first out. Okay, as simple as that. Nothing big or fancy about these two guys. So if you have an array and if you constrain the access of an array from last to first and then first in first out, that's called stack and queue. As simple as that. And putting a data into a stack is called pushing. I mean, instead of insert, we call that as a push. It's just a terminology which we use it. And while taking out, it's called popping. Okay, as we said, pushing and popping happens only on the one end, which is in the top. Okay, whereas in the queue, it is called NQ and DQ. So the NQ is done at the rear, whereas DQ is done at the front. Okay, as simple as that. So you push the queue, pull the queue out of it. Okay, it's pictorially straightforward. Uh, the code is also as easy as that figures. Okay, let's see that. Okay, so this is a class diagram for a stack or a UML diagram for a stack. When I say UML diagram, it's like a rectangular box and the title is the class name. The first box rectangle is called data members or properties or whatever it is. The second is the behaviors or functions or member functions, all those things. So we have what is the maximum size of array, and obviously, as I said, it was an array. A stack has a limited size, right? So I have declared a long array, and then the top is to keep the pointer, where my current position is. The array could be 100, but current filled item could be in 50 or 51. Okay, so that's where it is maintained by a top. Top is nothing but a integer value which maintains the position or the index of the last pushed item. Okay, one above the last pushed item, or top is last pushed item, correct? Okay, and we have simple functions: push and pop, peek and empty, full. It's all straightforward. Push is to put the data into the array. In that we'll get it and we'll check against the top element whether it's full or not. If it is not full, we'll push it. The vice versa, when we push it, pop it, we'll pick the value in the top index, and then we decrement the index. That's all it is. And I request you to play around with peek and empty and is full. Peek is nothing but without, I mean, it's same as pop but without taking it out. You just peep in and then see what is the value and then come out. You don't take the value out. And is empty is full is straightforward. So if the array is empty, or the stack is empty, the stack is full. Okay, let's look into the code. So let's visualize the code and put it. It's, as I said, it's an array, so I have drawn the array on the right hand side. So when item is pushed, let's say int, I check against the top. So when it is equal to the max size, I say that I can't push it and return -1. -1 is generally considered as a failure return. If the space is there, I increment the top to a one position and put it in that position. That's all. Very simple and sweet and straightforward. This push. Okay. The same way, let's see the pop. In the popper operation, what we'll do, we'll check whether the top is -1, which means that it is empty. We'll say that stack underflow, or we can print empty. It's up to you. If it is not, go to the stack and take the value and return it, and also do a minus minus. Minus minus is nothing but a C++ post decrement operator. C post decrement operator. If you are familiar with it, you know it. So nothing but it decrements the top value by 1 and stores in the same top. Okay, so that's the thing. So these are the simple operations, nothing fancy. If we move on to the queue, the same thing. So instead of top, we have a front, rear, and number of items. Okay, front is to identify where the front element is, and rear is to identify where I should put the new element, and then the number of items in the queue. Okay, you can straightforward implement these things and then do it. For example, insert, what you will do, I'll go to the front and then I'll go to the rear, and then rear of if it is a stack name is like q array of rear, I'll put that in the value if the queue is not full. Okay, first I'll check for the condition and then put it there. That's it. So the same version of stack the queue would be, but only the point of insertion is little different. Okay, here we are looking at the code. So first I check against the rear whether it's a max size or not. So if it is max size, so we'll say that the queue is full. I can print and then return, or I can return directly. It's up to our wish. If not, what we'll do? So else it comes here and checks for the front, and then adds a front, set the front to 0, and then rear we increment to 1, and then the place where we incremented we are putting the for the DQ. Okay, so if nothing is there, we return that queue is underflow or queue is empty. If not, we'll return the front value and then increment the front plus plus. Okay, these are simple and sweet code. Try to write the other functions in the same thing. You will be learning a lot in that. Okay, this is one of the famous interview questions, writing a stack. Okay, and there are a lot of applications that depends on that. Okay, thank you. Bye bye.